Hey, how's it going? If you're having trouble factoring at all, you have come to the right video. So this is a review of factoring you've learned in your beginning algebra class, in your intermediate algebra class. That may have been a very long time ago, but you need to be able to factor and factor well in a pre-calculus course and then next in a calculus course. And so I'd like to do just a review of factoring. I have a strategy here for you. Now we're not going to cover the entire strategy right here in this one page of a conversation, but I'm going to refer back to this list when we start talking about factoring problems. If you're given a problem in which you need to factor, and you know there are several reasons you might need to factor. You might need to factor if you are trying to solve a polynomial equation. Okay, the idea would be you set it equal to 0 and then you factor and you set each factor equal to 0. Or if you're trying to simplify a rational equation, okay, and what I mean by rational is fractions. So you have maybe a polynomial in the numerator and a polynomial in the denominator, and you would need to factor and cancel. And you've probably already done some of this in your pre-calculus course. But just to make sure we're all on the same page, let's do a review of these techniques of factoring polynomials. And again, on this page I have a strategy for you. First, is there a factor, a greatest common factor that would be factored out of every single term? Always look for that first. I've seen so many people run into difficulties because they forget to check if there's a greatest common factor. And then after that, you would consider several different options. Notice this 2a, a difference of squares. If you have a perfect square minus a perfect square, this will factor into a plus b times a minus b. Now, if you have a sum, if you were adding two squares together, that doesn't factor. So notice it's not on the list. Another thing is if you have a sum of cubes. Now, that does factor, unlike a sum of squares, and it factors into the cube root of each, so a plus b, and then you square the first term, you multiply these terms together, you change the sign and square the last one. We'll review that as well. Other things that could happen is a difference of cubes. Notice these formulas are almost identical, just with a sign change. Okay, if we check out part B, this is just factoring trinomials. Okay, so they could be perfect square trinomials. To me, I handle them all the same. Multiplies to be the constant, adds to me the x term. We'll take a look at those. Those show up probably the most frequently. And then factor by grouping. If you ever see 4 terms, you should try to factor by grouping. Once you're finished factoring, check to make sure you're really finished factoring. Sometimes your factors can be factored again. So that's step 3. Check to see if any factors with more than one term in the factor polynomial can be factored further. And we'll take a look at some of those problems as well. So now what I'd like to do is just a bunch of these problems, probably about 18 problems, that we just practice factoring. The directions here say factor the greatest common factor, but all of the other directions say factor completely. Here I just wanted you to focus on finding what is common to each of these 3 terms. Okay, so first just look at the numerical part. We have a 6, an 18, and a 12. So you're asking yourself what value divides into both 6, 18, and 12 without a remainder, or evenly is what we like to say. And that number is 6. 6 divides into 6, 6 divides into 18, and 6 divides into 12. But that's not all. Notice these all have a variable of x with different exponents. So we have an x to the 5th, which just means 5 x's multiplied together. We have an x to the 3rd, which means 3 x's multiplied together, and an x squared, which means 2 x's multiplied together. Now, anytime you have a variable common to all of your terms, in other words, a greatest common factor, the lowest exponent is what's going to come out. So remember, we have our 6 and we have our x squared that's going to come out in front of the parentheses. This is like reverse distributive property is what it is. Okay, now you really are dividing. So I'm dividing this by 6x squared, I'm dividing this by 6x squared, and dividing this by 6x squared. Now you don't have to write that down, but I want everybody to see what's really going on. So these 6's cancel, the x to the 5th and the x squared. Remember, you subtract exponents, so that gives you 1x to the 3rd. Do you have to write the 1? No, you don't, because this is multiplication. We'll simplify that shortly. Here the 6 goes into 18 3 times. The minus just comes down. And then x to the third over x squared, you subtract exponents and get x to the first. And once again, 6 goes into 12 2 times, so plus 2. And the x squared just cancel each other out to give you a 1, but 2 times 1 is really just 1. Now the way we would probably write that is 6x squared times x to the third, because 1 times x to the third is x to the third, minus 3x, that's an implied 1, plus 2. Now, whenever you factor out a greatest common factor, you probably should do this little check in your mind of, is that correct? And all you have to do is distribute it back inside just to check. So 6x squared times x to the third would be 6x to the fifth. 6x squared times negative 3x would be negative 18x to the third, and 6x squared times 2 would be 12x squared. Okay, so that's the idea of the greatest common factor. Now, if this said factor completely, what we would do is we would attempt to see if this part would factor. Now, I intentionally gave you a problem where what's in the parentheses does not factor further, but that would be the next step. All right, so for our second problem, x to the third plus 6x squared minus 2x minus 12. Now, over here to the right, I have our strategy listed. Okay, now, I know it's teeny tiny, but if you go down this list, okay, is there a greatest common factor? There's not. There's not a numerical value that it can be divided out of every one of these except one, which it's not a greatest common factor. And they all don't have x's, so there's no greatest common factor. Then we move down to these other options. You don't have two terms. That's what A speaks to. Do you have two terms? No, we don't. We have 4. B speaks to if you have 3 terms. We don't have that either. Down here, C, if there are 4 terms or more, try factor by grouping. So this is what this problem is. Now, when you factor by grouping, you can rearrange these in any order you like. I tend to just keep them the way they are to start with and see if it works. So factor by grouping is one of those things you just have to see if it works. If it works, you go on with it. If it doesn't work, then maybe it can't be factored. So you pull out what's common to the first 2 only. You ignore the rest of the problem. So what is a greatest common factor for x to the third plus 6x squared? And that's x squared. So if I factor out an x squared, remember that's going to leave an x here because I'm really dividing that by x squared, which is going to leave an x to the first. Plus, I divide this by x squared, the x squareds cancel, 6. Okay. Now what I'm going to do is look at my second set over here that I have grouped together. That's why they call it factor by grouping, and look to see what's common among these 2. Now they don't both have an x, but they do both have a greatest common factor of 2. 2 divides into 2, 2 divides into 12. So we need to pull out a 2. The question is, do we pull out a positive 2 or do we factor out a negative 2? And that depends on the first part of your problem. Now, I know they both are negative. If I do pull out a negative 2, notice what happens. The negative 2 comes out, that makes that a positive x. Negative 12 divided by negative 2 is a plus 6. Now, your ultimate goal is that these match. If you cannot get these to match what's in the parentheses, then factor by grouping does not work for that polynomial. Okay, that's why I factored out a negative 2. Had I decided to pull out a positive 2, over here on the right we would have a negative x and a negative 6, and then these 2 factors would not match. Now, we're not finished. The final step, possibly, you could have to go further, is to pull out the common x plus 6. You just write it one time. You don't write it twice because what you're doing is you're factoring out of this term and you're factoring out of this term. So you write it once times what's left out front. So it's going to be times x squared minus 2. Now I promise you, if you decided to check this by multiplying this back out using the distributive property, you would get your original polynomial back. It may not be in the same order, it might be, but no matter what, you should get those same 4 terms back. Let's check it. X times x squared is x to the third. X times negative 2 is negative 2x. 6 times x squared is 6x squared. And then 6 times negative 2 is negative 12. Now let's go check for all those terms. I have an x to the third first, a negative 2x is third on my list above, 6x squared is second on my list, and negative 12. So it checks out just fine. it's worth taking the extra bit of time to check it, especially when you're first learning to factor. Once you perfect your skills, you could probably check it in your head. So let's move on. All right, what do you think about this problem? When I look at this, I see a 9x squared minus a 144. And if I go down my strategy over here on the right, which is so teeny tiny, hard to see, but we have two terms. We have a 9x squared and we have a 144 with a minus in the middle. If I highlight what that is, that's this guy right here. That is a difference of squares. And when you factor a difference of squares, two things are very important. The first term is a perfect square, and you take the square root of that. Of both of these factors, the square root of 9 is 3, the square root of x squared is x. That goes in the first spot. So whatever the square root of the first term is, goes in the first spot. Then you take the square root of the last term, which is 144, the last term. The square root of that is 12. So 12 goes here, 12 goes here. Again, the square root of the first term goes in the first spot. The square root of the last term goes in the last spot. And then what you have to have memorized is that one factor is plus, one factor is minus. Okay? Now, check this problem out. We're not finished. Okay? So at first look, we had a difference of squares, and we factored. But watch this. We could have factored out a greatest common factor first, and I encourage that. That's what it says over here for strategy number 1, and I forgot to check. Now, does that mean I did it wrong from the beginning? No. I still see a greatest common factor in each of these. Let's pull out this 3, and that, y'all know that leaves x plus 4. In other words, I divided each of these by 3. Also, I have a 3 that comes out here, and that leaves, oh, don't forget to write the 3. So again, mistakes that can happen. If you pull out a greatest common factor, you must write it down. So that's times 3, and that also gives me x minus 4. Now don't leave it like that, because that 3 and that 3 factors can come out front. Now had I noticed from the beginning that I could have factored a 9 out initially, so watch this, it would have been 9 times x squared minus, now 144 divided by 9, and that's probably why I didn't think about it. I just don't think about that 9 divides into 144, but it does, and it does 16 times. And then you see you could go straight from here to here, because x squared minus 16 is also a perfect square. Two sets of parentheses, 1 plus 1 minus. The square root of x squared goes in the first spot. The square root of 16 goes in the second spot, but don't forget to pull your 9 down. Either way you get there is fine. So the good news is if you forget to factor out a greatest common factor, it's quite possible that you could still get to your final result by factoring out the last step instead of the first step. All right, so what do you think about this problem? I've got a 16x squared, that's a perfect square, right? I have a 25y squared, also a perfect square, and I have a plus in the middle. So if you go check your teeny tiny checklist over here to the right, I'm looking for A, if there are two terms, it might be a special form. So I look at my forms and I got a squared minus b squared, and I got a to the third plus a b to the third, and a to the third minus b to the third. I don't see an a squared plus b squared. Okay, you know why? Because there's not one. There is no a squared plus b squared factor. This is what we call prime. Another way to think about this is it does not factor. So that's going to be important to whatever problem you're trying to do. If you're trying to solve an equation, you would go one way from there. If you were trying to simplify an expression, you would know at this point that it doesn't simplify further. But I always want you to remember that a sum of squares is prime. It does not factor anymore unless there were a greatest common factor. Once again, I failed myself and you too. I forgot to look for a greatest common factor, but this did not have one. 16 and 25 don't have any factors in common. All right, let's take a look at 1 minus 36x squared. Now again, two terms. So I'm still dealing with strategy 2a over here. I go down on my checklist. Do I have an a squared minus b squared? Well, I have a minus, so that's good. Notice I have an a squared. 1 is a perfect square, and so is 36x squared. So you know what that means. That means this will factor into two factors, 1 plus 1 minus, or 1 minus 1 plus, whatever order you decide to put it in, with the square root of the first term in the first spot. So don't go putting 6x first. That's not how it works. The square root of 1 is 1. That goes in the first position. The square root of 36x squared is 6x. that goes in the second position. And that is your problem completely factored. How could you check it? You know what to do. You could FOIL it out. 1 times 1 is 1. 1 times negative 6x is negative 6x. 6x times 1 is plus 6x. And 6x times negative 6x is negative 36x squared. These cancel. So you get 1 minus 36x squared. All right, so it checks. Now this, of course, is the answer. We were looking for 1 plus 6x, 1 minus 6x. Again, important things there is two terms, perfect square, minus. All of those conditions had to be met to be able to factor this polynomial. All right, what about this problem? Okay, first thing, let's be good about this. Is there a greatest common factor? Is there something that factors into both 8 and 27? Is there a number that divides into each of those? And there's not. Factors of 8 are 2 and 4 and 8, and the factors of 27 are 3 and 9, so they don't have any common factors. Now, I move on, and I know that I'm dealing with this situation right here. I have two terms, okay? Now, is that an a squared minus b squared? No, that's not squared at all. Is it an a to the third plus b to the third? Nope, not at all. It's an a to the third minus b to the third. These are what we call perfect cubes. So I'm using this formula below. I'll explain it while we're doing the problem. Okay, you're going to always factor these cubes into what I call a short set and a long set of parentheses. Do the short set first. You need to take the cubed root of each of these factors. The cubed root of 8 is 2. The cubed root of x to the third is x. We'll do the same thing with 27. The cubed root of 27 is 3. Why? Because 3 times 3 is 9 times 3 is 27. In other words, a cubed root is a number you multiply times itself 3 times to get that value. Now, whatever operation is in the problem is what goes here. So had that been a plus, you could factor it and you would get a plus. But since that's a minus, I pulled down a minus. Now, here's where it gets interesting. This first term over here is you square the first one. So I'm going to square 2x. That means square both of these factors. 2 squared is 4. X squared is just that, x squared. Okay, so you square the first. The middle term, you multiply these two together. So for this middle term here, you multiply. Okay, so 2x times 3 is 6x. Now, I didn't put an operation here. It is plus. The reason it's plus is because this is always the opposite of this. So that's the opposite of whatever you start with. Okay? And then the last term is the last one squared. So what I mean by the last one, the 3. 3 squared is 9, and that is always plus. So you just have to remember that the last one is always positive. The middle one is just the opposite sign of whatever you started with. And by the way, this is completely factored. How could you check it? Let's do it. You can multiply all this out. 2x times 4x squared is 8x to the third. 2x times 6x is 12x squared. 2x times 9 is 18x. Then I do negative 3 times 4x squared is negative 12x squared. Negative 3 times 6x is negative 18x. Negative 3 times positive 9 is minus 27. You might be getting nervous, but look. That cancels with that cancels with that, and I have 8x to the third minus 27. Here's another tidbit of information. This polynomial over here, it's called a trinomial because it's got 3 terms. It will not factor again. So anytime you factor a difference of cubes or a sum of cubes, you don't have to worry about that second polynomial factoring again into, say like 2x plus 3 times 2x plus 3 or something like that. You won't have to worry about that. We haven't done those types of problems yet, but you won't have to worry about that happening. Okay, last problem I want to do in part 1 of the video, then we'll do a part 2 of the video and work on trinomials. But notice I have 2 terms here. Better yet, let's back up. Is there a greatest common factor? Is there something in common to 125x to the third and y to the sixth? And there's not. You've got a 125 and a 1 here, no common factors, and x's and y's here, no common factors. So we move on to the strategy 2a. Do you have 2 terms? Yes, we do, and we have a sum of cubes. That's that middle guy. Okay, so remember from the last problem, the explanation is you take the cubed root of the first term. So the cubed root of 125, you're going to ask yourself, what do you multiply 3 times to get 125? It is 5. And the cubed root of x to the third is x. Then we take the cubed root of y to the 6th. Now that's interesting. What do you want to multiply 3 times to get y to the 6th? And that's y squared. When you take the cubed root of an exponent, you're really just dividing it by 3. Okay? Or you think y squared times y squared times y squared. Yes, that's y to the 6th, right? Whatever operation you have in your problem is what you put in the first factor. Now the remaining just follows from here. So we square the first term. Don't forget to square the 5 and the x, which is 25x squared. Whatever operation is here, which matches that, is the opposite here. So if that's plus, that's minus. If that were minus, that'd be plus. You multiply these two together to get the middle term. So 5x times y squared is just that, 5xy squared. And then you square the last term. So y squared is y to the 4th. And then this is always plus. It doesn't matter what the original problem says. This is always plus. And we are finished with that problem. So I hope you'll join me for part 2 of the video where we work on factoring trinomials and we work on factoring problems that have several steps.